Whenever an acid is dissolved in water, it dissociates to give us ions. For example, HCl, hydrochloric acid, when it is dissolved in water, it dissociates to give H plus and Cl minus ion. Similarly, HNO3, nitric acid, when dissolved in water, it gives us H plus and NO3 minus ions. This dissociation of ions is what happening when an acid is reacted with water. So let's learn the same thing with an experiment. Here I am taking sodium chloride crystals in a test tube and I added some drops of concentrated sulfuric acid into this sodium chloride crystals, and the reaction if this experiment follows is 2 NaCl plus H2SO4 gives 2 HCl plus Na2SO4. That is, as a result of the reaction between sodium chloride and concentrated H2SO4, we are getting dry hydrochloric acid in the gaseous state along with Na2SO4. That we know that HCl is an acid. So obviously, if an acid gas is generating here, then it can be tested using a blue litmus paper. If a substance have acidic property, then the blue litmus paper should change its color to red. So I place a blue litmus paper at the mouth of this test tube so that the hydrochloric acid gases coming out of the test tube may fall on this litmus paper. But now, as you can see, here there is no color changes happening to the blue litmus paper. I take the exact same blue litmus paper and dipped in water. Now, my blue litmus paper is wet, and I place that wet blue litmus paper in the mouth of this test tube. And now, as you can see, the color of the blue litmus paper changed to red. It means that HCl, hydrochloric acid, combines with water to give us H plus and Cl minus ions. It means the acidic properties of a particular substance is visible only in the presence of water. Also, this H plus ion, which is formed as a result of the dilution of HCl in water, is not stable. It is highly unstable. So, this H plus immediately combines with another water molecule to give us H3O plus. That means hydronium ion. So the thing you have to realize is that the reason for acidity, or when an acid is dissolved in water, it releases H plus ions, and this H plus ions are responsible for the acidic properties. Similarly, when any base is dissolved in water, just like in the case of acid, it gives us the corresponding ions. Here, NaOH when dissolved in water gives Na plus along with OH minus ions. KOH gives K plus and OH minus ions, and MgOH twice gives Mg2 plus and 2 OH minus ions. Here, as you can see, OH minus ions is common in all these three reactions. That is, bases generate OH minus ions in water. But do not think that all bases gives us OH minus in water, because only certain bases are soluble in water. Those bases which are soluble in water are known as alkalis, and those alkalis will give us OH minus ions in water. Now, when any acid or base is added to a water, the concentration of H plus or OH minus ions in that water is decreasing considerably. As you can see, here I am taking sulfuric acid, and in this entire beaker of water, the concentration of H plus ion which is present in H2SO4 is very less when compared to the total volume of water. That means the concentration of H plus is decreasing when an acid is introduced into water. Similarly, when a base is introduced into water, the concentration of OH minus is decreasing considerably. And this process is known as dilution. Mixing acids or bases with water decreases the concentration of H plus or OH minus ions. This is the process known as dilution. And during dilution, always remember that do not add water to acids or bases to make it dilute, because the process is highly exothermic and a large amount of heat energy will be released, and as a result, the particular acid or base may splash out and it may cause harm to the person who is doing the experiment. So for diluting a particular base or acid, what we are doing is we have to add the acid or base to water to make it dilute.